Good morning, I am DR.Baneswar. Today I am going to make a video on middle ear.
Hello, sir.
These are the three ossicles. This is the stapes bone. This one is the stapes, and the incus and the malleus. Stapes is stirrup shaped. This is the incus anvil shaped premolar tooth, and is the malleus hammer shaped. So these are the three ossicles. Malleus and incus develop from the first pharyngeal arch, and malleus incus, then stapes from the second pharyngeal arch. This is the temporal bone. This is the temporal, the right temporal bone and left temporal bone. So this one is the left temporal bone, and is the right temporal bone. This is a petrous part. Petrous part of the right temporal bone. This is a squamous part. Mastoid part. Then is the tympanic part. This is the tympanic part, and is the stylar process. This one is the stylar process. So these are the 5 parts: petrous, squamous, mastoid, tympanic, and stylar process. So within this temporal bone, there will be the middle ear. So if we cut this temporal bone in a sagittal plane, so this is the section. This section. This is the right temporal bone. This is the medial half and is the lateral half. So if we cut sagittally, so this is the middle ear cavity. This is the middle ear cavity. Now we will discuss the walls of the middle ear. This is the right temporal bone. So this is the roof. This roof is called tegmen tympani. This is the tegmen tympani. It is called tegmen tympani. In the anterior surface of the petrous part of the temporal bone, this is the anterior surface. The anterior surface of the petrous part of the temporal bone, and this is called arcuate eminence. Just lateral to this arcuate eminence, this is called tegmen tympani. It is the roof of the middle ear. This is the tegmen tympani, just lateral to the arcuate eminence. So this is the tegmen tympani. It's a roof. Then this is the medial wall. So in this medial wall there is a bony elevation. This is the bony elevation that is called promontory. This is the bony elevation promontory that is due to the basal turn of the cochlea. So we'll see the cochlea later on. So just above the promontory there will be the ovilundo or fenestra vestibuli, and behind the promontory there will be the raunundo. Okay, then this is called superomedial border of the middle ear. So it's a medial wall. Is the medial wall of the right middle ear, and is the roof, tegmen tympani. So this is the superomedial border of the middle ear. In this superomedial border of the middle ear, this is the facial canal. This is the second part of the facial nerve. There is in the facial canal. Second part of the facial nerve. Then is this third part of the facial nerve which emerges through the stylomastoid foramen. So this is the stylomastoid foramen. This one is the stylomastoid foramen. So is a roof. Roof is the tegmen tympani with the medial wall. In this medial wall, promontory, then ovilundo, then raunundo, then in the superomedial border of the middle ear is the facial canal. Just above the second part of the facial nerve, the facial canal, this is the lateral semicircular canal. Now This is the anterior wall. This is the anterior wall. In this anterior wall, this is the canal for muscle tensor tympani. It is the canal for the muscle tensor tympani, and it is the Eustachian tube. In the anterior wall, this is Eustachian tube or pharyngotympanic tube. So these are the two canals in the anterior wall. Then lateral wall. Lateral wall is the tympanic membrane. This is the tympanic membrane. This one is a tympanic membrane. This is a lateral wall. Then posterior wall. The posterior wall is mastoid bone having the mastoid hair cells. These are the mastoid hair cells, and this is the common part. This is the mastoid antrum. This is the antrum. This is mastoid antrum. In the posterior wall, having the third part of the facial nerve. Then floor. This is the floor. This is the floor of the medullary. This is the floor of the medullary, which is known as the jugular fossa. This is the jugular fossa. This is the jugular fossa. This is a floor. So this is the medullary. This is the medial wall, anterior wall, posterior wall. Roof is the tegment tympani. Lateral wall is the tympanic membrane. This is the external acoustic meatus. Then this is the tympanic membrane. Okay. Then this floor is the jugular fossa. So here we can see this is the jugular foramen. This is the jugular foramen. Just lateral to the jugular foramen, this is the jugular fossa. Please focus it. This is the floor. The jugular fossa is the floor. So in the jugular fossa, this is the bigger model. Suppose this is the floor of the medullary. So this in the jugular fossa, there will be the starting of the superior bulb of the internal jugular vein. This is the superior bulb of the internal jugular vein, which lies in the jugular fossa. So these are the walls. These are the walls of the medullary. So now this medullary is connected entirely with the nasopharynx. That is the pharyngotympanic tube. Medullary is connected entirely with the nasopharynx by this Eustachian tube or pharyngotympanic tube. Then this the medullary is connected posteriorly with the mastoid antrum. So this is the mastoid antrum. This cavity is the common cavity of the mastoid hair cell. That is the mastoid antrum. So this mastoid antrum is connected anteriorly to the medullary. So this is called editous. This is called editous. This is the editous. Editous is the connection. Editous is the connection between the medullary and mastoid antrum. This is the mastoid antrum, mastoid hair cells, and anteriorly medullary. These are the connection of the medullary anteriorly with the nasopharynx, posteriorly with the mastoid antrum. So these are the walls of the medullary. So this is a bigger model. So this is the tympanic membrane. This one is the tympanic membrane. And this one is a malleus bone. This is malleus bone. Then is incus, and this is the stapes. Stapes. So this tympanic membrane is a 55 square millimeter. The area of this tympanic membrane is 55 square millimeter. Then is the footplate of the stapes. Footplate of these spaces, which is 3.2 square millimeter. So this tympanic membrane is in the tympanic sulcus of the tympanic bone. Now, so this is the ovilundo, fenastra vestibuli. So this footplate, footplate of the stapes bone is attached in this ovilundo. Okay. Now these are the three earocicles. These three earocicle, malleus is attached with the tympanic membrane. Then malleus articulates with the incus bone, that is the saddle variety of synovial joint. Then this incus articulates with the head of the stapes bone, that is ball and socket variety of synovial joint, and is the muscle stapedius. This stapedius muscle is attached in the neck of the stapes bone. This is the muscle tensor tympani. So this tensor tympani lies in this canal for muscle tensor tympani. Okay, so this is the canal in the anterior wall of the medulla. This is the canal for muscle tensor tympani. So this is the tensor tympani muscle, and this is the stapedius muscle. Tensor tympani muscle developed from the first pharyngeal arch, which is supplied by the nerve of the first pharyngeal arch, and is the muscle stapedius muscle. This focus. So this is the stapedius muscle, which is developed from the second pharyngeal arch, and it is supplied by the facial nerve. So these are the earocicles. So the tympanic membrane vibrates. And the sound will disturb the tympanic membrane. Then later on there will be the vibration, and the vibration will be, this sound will be converted into mechanical energy by these three earocicles, malleus, incus and stapes. So this is the medial wall of the medulla. In this medial wall is the ovilundo. This is the ovilundo. So just medial to this ovilundo there will be the vestibule. So this cavity is the vestibule. This cavity is vestibule, and this is for the cochlea. This is for the cochlea. So this cavity is the for vestibule. Okay. So now we'll see the vestibule. So this is the medullary cavity. In the bigger model, this is the medullary cavity. In this medullary cavity, this is the within the right-sided temporal bone. It is within the right-sided temporal bone. So this is the promontory. This promontory is due to basal turn of the cochlea. Suppose this is the cochlea. This is our cochlea. The promontory. Above the promontory, this is the ovilundo. This is the ovilundo. So this ovilundo is obliterated by this footplate of the stapes. Footplate of the stapes. Now the medulla is the cavity containing the air. So just medial to this medulla, this is the vestibule. This is the vestibule. This vestibule is also known as the bony labyrinth. It is also known as the bony labyrinth containing the perilymph. This is the vestibule. So in this vestibule, there will be the membranous labyrinth. So this is the membranous labyrinth. Within the vestibule, I mean the bony labyrinth, containing the perilymph. So within this bony labyrinth, this is the membranous labyrinth. This is membranous labyrinth. Membranous labyrinth. This is the saccule. This one is the saccule, and this is utricle. This utricle is connected with the semicircular canals. So this is the membranous labyrinth, and this is the saccule. This saccule will be connected anteriorly with the cochlear duct or scala media. So right now, this is our medullary cavity. Medullary cavity containing air, and this is the ovilundo. So this ovilundo connects middle ear to the inner ear, mane vestibule. This is the vestibule, bony labyrinth containing the perilimb. Now this perilimb of this vestibule will extend anteriorly towards the cochlea, being the scala vestibuli. So there are three pipes. There are three pipes which will extend anteriorly 2 and 3, making 2 and 3/4 turn, making 2 and 3/4 turn up to the apex. So this perilimb, the perilimb which is present within the bony labyrinth, I mean the vestibule, it will extend anteriorly, being the scala vestibuli, up to the apex of the cochlea. From the apex, it again comes back. It again comes back as a scala tympani. And this is the proximal one. The proximal one is the scala vestibuli, and this distal one is the scala tympani. So this scala vestibuli containing the perilimb from the vestibule extends towards the cochlea as a scala vestibuli up to the apex. From the apex, it again comes back. It again comes back as a scala tympani, and finally it opens. Finally, it opens in the medial wall of the middle ear as a round window. This is called fenastra cochlea. This one is the fenastra vestibuli, and this is the fenastra cochlea, which is bounded by a membrane. So this is about the scala vestibuli and scala tympani. So the common part between the scala vestibuli and scala tympani is called helicotrema. Helicotrema. So this is the cavity which is known as the bony labyrinth containing the perilimb. Okay. So this perilimb extends entirely along the scala vestibuli, and it again comes back as a scala tympani, and finally it opens in the round window. Okay. In the round window. Now this is the membranous labyrinth. This is the membranous labyrinth. This part is called saccule and utricle. And the saccule will be connected anteriorly to the scala media. So there are three pipes. Proximal is the scala vestibuli, and this distal is the scala tympani. In between the scala vestibuli and scala tympani, this middle one is the scala media. So this scala media is the middle pipe. So this middle pipe, the apex of this middle pipe, scala media, is blind. It is blind. So this scala media or cochlear duct will be connected with the saccule as a ductus reunions. It is called, this one is the ductus reunion. Please focus it. So this one is the ductus reunions. This is the ductus reunions which enter to this saccule. So this membranous labyrinth, this blue part, membranous labyrinth contains endolimb. Okay, endolimb. So sometimes the endolimb within this membranous labyrinth production may be increased. In that condition, this endolimb will be drained to the subarachnoid space by this endolymphatic duct. This is called succus and ductus endolymphatic duct or endolymphatic duct that drains in the subarachnoid space. So this endolymphatic duct transmit through this aqueduct of Sylvia. So the aqueduct of vestibule. This is called is a slit-like opening in the posterior surface. In the posterior surface of the petrous part of the temporal bone is a slit-like opening. This one is a slit-like opening. So through this slit-like opening, this succus and ductus endolymphaticus or endolymphatic duct transmits, draining the endolimb in the subarachnoid space of the posterior cranial cavity or posterior cranial fossa. So this is the membranous labyrinth. So the sound energy strike over the tympanic membrane. Now this sound energy is converted into mechanical energy by this ear ossicle, Lelius, Incus and Stapes. Okay. Then this mechanical energy will disturb the perilimb present in the vestibule. The perilimb within the vestibule will be disturbed. So now this disturbed perilimb will propagate along the scala vestibuli, and it will again come back along the scala tympani, and this disturbed perilimb coming back through the scala tympani will be final drop in the round window. Okay. Now this disturbance of the perilimb in the scala vestibuli and scala tympani will also disturb the scala media. This is the scala media or cochlear duct. So within the cochlear duct there will be the endolymph. Okay, now this disturbed endolymph within the cochlear duct will disturb the organoportin receptor present in the cochlear duct. Within the cochlear duct there will be the organoportin receptor, especially the hair cells. The hair cells of the organoportin will be stimulated. Then there will be starting of action potential. So this action potential will be carried along the neurons. So this is the bipolar neurons. In this model, this is the cochlear duct. This is the cochlea. So this is the cochlear duct. It is blind in the apex. So this cochlear duct containing the endolymph. So due to the disturbance of the perilimb traveling through the scala vestibuli and scala tympani will disturb the endolymph of this cochlear duct, and this within this cochlear duct there will be the organ of Corti. The organ of Corti containing the hair cells will produce the axon potential, and this axon potential will be received by these bipolar neurons. So these are the bipolar neurons forming the spiral ganglion. This is the spiral ganglion making the by the bipolar neuron. So this is the cochlear nerve. This is the cochlear nerve which will transmit along the internal acoustic meatus. So this is the internal acoustic meatus. This is internal acoustic meatus. So through this internal acoustic meatus there will be the exit of a cochlear nerve. So this cochlear nerve, this is the cochlear nerve starting from the organ of Corti within the cochlear duct or scala media. So this cochlear duct, first order neuron, I mean the bipolar neurons are the first order neuron. Then they will synapse with the cochlear nuclei, cochlear nuclei of the medulla. Then from this cochlear nuclei it will be carried to the superior olivatory nuclei. Then it is carried to the inferior colliculi. From the inferior colliculi it will be taken to the medial geniculate body. From the medial geniculate body it is taken to the auditory area number 41 and 42 by the sublentiform part of the internal capsule, which is also known as the inferior thalamic radiation. Okay. Now we will discuss the vestibular nerve. So this is the sacule and utricle. Sacule is small, utricle is large. Though this is the membranous labyrinth containing the endolymph. So it is within the vestibule. So this sacule and utricle are floating within the vestibule. So this sacule and utricle. So this sacule containing the three semicircular canals. These are the three semicircular canal. So this is the anterior or superior semicircular canal. This is the posterior semicircular canal, and is the lateral semicircular canal. Okay. So this anterior semicircular canal and this posterior semicircular canal communicate. These two semicircular canals will open to the utricle by a common opening. This is called crasscomony. This part is called crasscomony. Then the other openings of this superior semicircular canal, posterior semicircular canal, lateral semicircular canals opening to the utricle are having a dilatation. This is called ampulla. This is called ampulla or dilatation. So this ampulla is not present in the crus communi. Yeah, ampulla is not present in the crus communi. So this ampulla contains crista ampullaris. This ampulla contains crista ampullaris, that is the receptor for kinetic balance. Okay. So these semicircular canals are 2/3 of a circle. The measurement of the semicircular canals are 2/3 of a circle, and they are 90 degree to each other. They are 90 degree to each other. Okay, containing endolymph. Okay. Now this is the anterior or superior is the highest. So due to the presence of anterior or superior semicircular canal, there is an arcuate eminence. This is the arcuate eminence in the anterior surface. In the anterior surface of the petrous part of the temporal bone, this is called arcuate eminence, just medial to the tegmen tympani. This is the tegmen tympani roof of the middle. So just medial to the tegmen tympani, this is the arcuate eminence. This arcuate eminence is due to the presence of superior semicircular canal. Then this lateral semicircular canal is just over the facial canal. So when we do this section, this is the medial wall of the middle ear. So this is the facial canal. This is the facial canal. Please focus it. Facial canal. Just above the facial canal, this is the lateral semicircular canal. This one is the lateral semicircular canal. So this is the lateral semicircular canal. So in this dilatation, I mean the ampulla, so there is the receptor for kinetic balance, that is called crista ampullaris. Crista ampullaris. So this is the vestibular nerve. So this is the vestibular ganglion, vestibular nerve ganglion. The vestibular nerve ganglion lies in the internal acoustic meatus. So this is the internal acoustic meatus. So in this internal acoustic meatus, this is the vestibular nerve. So other component of the vestibular nerve, so that start from the saccule and utricle. So that receptor for static balance is the macule. So macule lies within the saccule and utricle, and this receptor for the kinetic balance lies within the ampulla, that is the crista ampullaris. So whenever the body moves, so this endolymph present within the semicircular canals also move, and due to the movement of this endolymph present within the semicircular canals will stimulate the crista ampullaris for kinetic balance. So when this endolymph is in rest, then in that condition the macule which is present within the saccule and utricle take the upper end. So this vestibular nerve, central process will go and connect or stimulate the cranial nerve nuclei, 3rd, 4th and 6th cranial nerve nuclei. 3rd means oculomotor nerve nuclei, then 4th cranial nerve nuclei and 6th cranial nerve nuclei will be stimulated by the central process of this vestibular nerve. So as a whole, this is the vestibulocochlear nerve. Now the concentration of the perilimb is high sodium. The concentration of the perilimb is high sodium, then low concentration potassium. So by the mnemonics HSLC, private or Punjab. HSLC private or Punjab means high sodium and low concentration of potassium of perilimb. Then its opposite is the concentration of endolymph. Low sodium and high potassium. So this is about the middle ear. So here also you see this is the middle ear. Lateral wall is the tympanic membrane. So this is the tympanic membrane. Then this is the malleus, incus and stapes. Then is the anterior wall. This is the muscle tensor tympani. In the anterior wall, and is the pharyngotympanic tube. The roof is formed by the tegmen tympani. Posterior wall is formed by the mastoid air cells and mastoid antrum, and is the editas. Editas connects middle ear with the mastoid antrum. Then is the floor. The floor is having the jugular fossa. The jugular fossa is the starting of the superior bulb of the internal jugular vein, and medial wall is the medial wall. The medial wall showing the promontory. Promontory is the bony elevation in the medial wall of the middle ear. Then is the ovidundo. Ovidundo is obliterated by the foot plate of the stapes. Then is the rounundo. Rounundo is also obliterated by a membrane. Okay, so this is the muscle stapedius in the posterior wall of the middle ear. Stapedius muscle. Stapedius muscle is attached anteriorly to the neck of the stapes bone, and is the muscle tensor tympani. Tensor tympani is attached in the tympanic membrane. Okay, so this is about the middle ear. Thank you.